In solid state, you might have learned SCC unit cell, BCC, FCC, CCP as well as SCP unit cell. Always keep in mind the number of atoms in SCC unit cell is 1. Number of atoms in BCC unit cell is 2. Number of atoms in FCC unit cell is 4. Number of atoms in CCP is also 4. And the number of atoms in SCP unit cell is 6. Okay. Now we determine radius for each unit cell. The radius formula for SCC unit cell, that is A by 2, where A is edge length. For BCC, radius formula is under root 3 by 4 A is there. Okay, for FCC unit cell, we have the formula A by 2 root 2 is there. Okay, for CCP, also same formula because FCC as well as CCP are same. So we have the same formula A by 2 root 2 is there. Then we have SCP. The formula, radius formula for SCP same as in case of SCC also. We have A by 2 is there. Okay, we got the radius formula for each unit cell. Now we talk about the packing fraction. Okay, so packing fraction, it is the space occupied by the atom. So we have to calculate in the percentage. So always keep in mind packing fraction for SCC unit cell is 53%. Packing fraction for BCC unit cell, that is 68%. Packing fraction for FCC, that is 74%. And for CCP, it is also 74%. And always keep in mind for SCP also packing fraction is 74%. Now we calculate void, empty space available in a unit cell. Okay, so packing fraction we calculated the space occupied by the atoms. To determine the empty space, we can subtract these values from 100. Empty space available, the percentage of empty space available in SCC unit cell, 100 minus 53 will get 47%. 47%. Voids in BCC, it will be 32%. Voids in FCC, it will be 26%. Here also we have 26% and it is also 26% is there. Okay, now we have coordination numbers. Always keep in mind coordination number for SCC unit cell is 6. Coordination number for BCC unit cell is 8. Coordination number for FCC unit cell is 12. Coordination number for CCP is also 12, as well as for SCP unit cell coordination number is also 12. Okay, now we talk about octahedral void as well as tetrahedral void. So always keep in mind the number of atoms are equal to octahedral void, and octahedral void is equal to twice of tetrahedral void. This is the relation we use to determine the number of octahedral void as well as tetrahedral void. For example, in SCC unit cell, the number of atom is 1. Then the number of atom is equal to octahedral void. Then we can say 1 octahedral void is present in a unit cell. What kind of unit cell? SCC unit cell. Okay. Number of atom is equal to number of octahedral void. In BCC, number of atoms are 2, then octahedral void will be 2. In FCC, number of atom 4, then octahedral void 4. In CCP, octahedral number of atoms 4, then octahedral void will be 4. In ICP, number of atoms are 6, then octahedral void will be 6. Okay. Now to determine tetrahedral void, we can multiply by 2. What? Octahedral void. We can multiply these values by 2 to determine tetrahedral void. So multiplied by 2, 2 1 are 2, we get 2 2 are 4, 2 4 are 8, 2 4 are 8, 2 6 are 12 are there. So these are the values for the number of tetrahedral void in each unit cell. If you like this video, please share and subscribe to the channel.